minutes.
So an influencer, this is happening a lot, a lot of avatars being the influencers in Instagram, for example. Nelly, so this is something to think about.
That's cute. Well, the avatar can do a lot. It can go from side to side. It can go back and forward. Well, not really, but it can move, open its mouth, close its mouth, open, close. So it can do a few things, but it's pretty primitive on Zoom. I mean, Zoom promised to have something better, but it didn't. So Dr. Ramesh, you look wonderful. I mean, the quality of your internet connection. I was just remembering the past, what it looked like with the monsoons and the problems that we had. I don't know if you don't see the difference, but I see it.
Yeah, certainly. Thank you.
And you know what? On Zoom now, they're giving us only 720p instead of 1080, so that the videos, everything comes out, like watered, washed out colors in the recordings. I'm looking for something better, but I haven't found it yet. There, you can see my head going to one side and then the other side. See, it can do something, Doris, not much, but. Oh, lovely colors. Ah, beautiful. That's a good point, Henda. Henda mentioned that routines also foster motivation. That is so true. Is that a question, Nicole? Yes, I think you have audio rights. Yes, this is through Zoom. If it weren't, I would use a better. I have a few avatars that are much better than this. No, this is not good at all. All right, so welcome everyone. Welcome to day 2 and our next presentation of MMVC23. Thank you for joining us. Spread the word to your friends in case they're missing out, and they are missing out. We're in India. I don't know if you've been to India, but that's where we are right now. Our presenter is coming to us from India. So imagine that you're there with our presenter. Dr. Ramesh Sharma teaches instructional design in New Delhi at Ambedkar University. He has taught. Oh, you can pronounce it for me if I mispronounced it, please.
That's fine.
Oh, it was? Okay.
Yes.
Educational Technology and Learning Resource at Wawasan Open University in Malaysia. He is an expert in open and distance and technology-mediated learning and has served as a visiting professor at Universidad. I can't say that. Maybe you can. I don't know if you speak Spanish.
It is
How would
Portuguese.
you pronounce?
University Estado da Bahia.
Yeah, that sounds quite...
Bahia is the second largest state in Brazil after
in
São
Brazil.
Paulo.
Thank you.
Yeah.
Visiting professor at the University of Fiji. And of course, he also was the director of distance education at University of Guyana, that I can pronounce.
Oh, that is a wonderful country.
He has also, in case I missed it, he was also involved with the Commonwealth of Learning and specifically Wiki Educator, where we both worked and volunteered. And he's also the regional director of Indira Gandhi. Are you still National Open University in India? Is that where you currently work?
No, I worked there before joining Commonwealth of Learning.
Okay. All right.
Yes.
So it gives me a great pleasure to introduce you to my dear friend. I
Thank
feel
you,
like we've
thank you
known
so
each other
much.
forever because we have since the early 2000, I presume. So it's
Yes.
probably over 20 years, I think, to
Yes.
our session at MMVC 23. So welcome.
Thank you. Okay, friends, and good morning, good afternoon, and here in India. It looks like today it is the most of the presentations, they are by us from here in India. So let me begin. In fact, when I was thinking of this topic, I had this feeling, and I still have this feeling, that quantum computing is a bit technical subject, and it is not yet talked about much. And that's why that is the reason I wanted to go with. Nelly, can you confirm you see my screen?
Yes, I see your screen, but
Okay.
maybe you can bring your mic a bit closer because I had to raise my volume.
I think I need to. Okay, I'll try to speak a little bit louder
Yeah,
because
thank you.
my microphone I'm using this laptop microphone with me. So what has happened that very recently the government of India has announced a national quantum mission, and quite a substantive sum of money has been sanctioned to carry out the work on quantum computing for the next 7-8 years of that. So, and means this is being considered as the next technological revolution. Currently, we are in the era of AI, artificial intelligence, and quantum computing is altogether a different kind of computing field. And it got much into discussion, I think 2 years ago or 3 years ago, when Google announced their quantum computer, and they highlighted a study conducted by them that the supercomputers of today, they are very powerful. In fact, most of our activities currently right now, global scale, are being handled by these supercomputers of today. So they did a study that there is a problem, and that problem, to solve that problem using these powerful computers of today, it takes around, say, like 10,000 years. But the quantum computer, which was created by Google, they say that our computer can solve it in 200 seconds. And now we can see the range, that 10,000 years on one side and 200 seconds on one side, to show the power of these computers. And in fact, if we show the photograph of a quantum computer to someone, nobody will say that it can be a computer. It more looks like a chandelier, hanging from the roof, like that. But those are the tubes, which because it involves a lot of cooling. So hardware point of view, from aesthetics point of view, from design point of view, it's altogether a completely different kind of thing. So before we go into that, let us first understand that how quantum computing or this quantum phenomena, it helps us. And these are some of the examples which we see on daily basis, but we may not be aware that how these work or how the quantum phenomenon, it helps us. Say, for example, LED, the light emitting diodes, they use quantum dots. And these are tiny crystals made of semiconductor material, which converts electricity into light. These quantum dots, they get into the excited state when the electric current flows from them, causing them to emit the light. And this process is based on the principle of quantum confinement, where the quantum dots are so small that they can only contain a limited number of electrons, leading to unique optical properties. So that goes with that. And then the most common device, I think everybody who uses computer nowadays, works on computer, uses printers. And this is the image of a laser printer. And these laser printers, they also work. They use laser to create patterns of light on a paper, which are then absorbed by the toner particles to form the images. So the laser technology used in these principles, they relies on the principle of quantum mechanics, specifically the concept of wave-particle duality. Means whether it is a wave or a particle, where light can behave both as a wave and a particle. In fact, it is quite strange, means an interesting thing that there are some Nobel Prizes given. I will recall the name of those scientists. So the first one said that it is a wave, got the Nobel Prize. Another said that it's particle, got the Nobel Prize, and third one said it is both. So that goes. The another most common device, like we use even the smartphones and other mobile devices, they use quantum dots in their display to improve the brightness and color accuracy. These quantum dots are also used in some medical imaging techniques, such as positron. We call it as PET scan, positron emission tomography from there. And these flat screen TVs or monitors, which use LCD, the liquid crystal display technology, also relies on quantum mechanics to control the orientation of molecules in a layer of liquid crystal. And when an electric current field is applied to this layer, the molecules can be aligned to either allow or block light from passing through, creating images on the screen. And then these kitchen appliances, like microwave ovens, they use quantum mechanics to heat food. Microwave ovens work by causing water molecules in the food to vibrate, generating heat through the process of dielectric heating. And this process is based on the principle of quantum mechanics, where the microwaves cause the water molecules to absorb energy and vibrate at specific frequencies. Similarly, refrigerator magnets, they are made of material which exhibit ferromagnetism. And it is a property that arises from quantum mechanical behavior of electrons in iron, nickel, and cobalt. And when these materials, they are placed near a magnet, the electrons in these materials align with the magnetic field, creating a strong attraction between the magnet and the material. And then we have these window glasses. The glass is made of sand, and that has been heated to extremely high temperatures and then cooled slowly, allowing the grains to settle into a crystalline structure. Although we know that this process is called as annealing, and it relies also again on quantum mechanics to control the movement of atoms during the process of cooling process. And then thermal insulation, for example, like in fiberglass, to reduce the heat transfer. These materials, they contain very thin fibers that are designed to trap air molecules, reducing the amount of heat that can be transferred through the material. And this effect is based on the principle of quantum statistical mechanics, which describes the behavior of large ensemble of particles by growing from there. So this is here. So what is quantum computing? Means it is a cutting edge paradigm in information processing, which leverages the principles of quantum mechanics to perform complex computations. And here, unlike classical computing, which relies on bits like 0 and 1, the quantum computing uses quantum bits, or in short, we call them. This is the photograph of a quantum computer. Nobody will say that this can be a computer, but when we have seen so much of the classical computers. So we call them as qubits rather than bits, which are 0 and 1 here, which can exist in multiple states simultaneously. So it can be like in classical computer, we say that 0 is off state, 1 is on state. So either it is off or it is on. But here it can exist in multiple states. So it can be off, it can be on, and it can be in between as well. That's a phenomenon called as quantum superposition. And this unique property, it allows these computers to process huge amount of data in parallel, like solving certain problems exponentially faster than the classical computers. So like if we toss a coin in the air, we can be either like getting a head or a tail. So that, but in quantum computing, the quantum coin can exist in a superposition of both heads and tail states simultaneously. That goes with that. If we see the historical development of quantum computing, there are significant contributions from scientists and researchers. In fact, if you see, it is believed that it began with this paper by Richard Feynman, which he wrote in 1982 about simulating physics with computers. He introduced the concept of quantum simulation and inspired the development of quantum computer. And here you can see that how from Max Planck hypothesis to other Bell equality, quantum information theory, and the recent ongoing developments, how this field is progressing so very well. So what is means the state of classical computers versus quantum computing? And particularly in this Shor's algorithm, it plays a very, very significant role. So quantum classical computers process data using bits that represent either 0 and 1, whereas the quantum computers, they leverage qubits with quantum states, allowing for exponential parallelism in the computing. And this means this Shor's algorithm is very helpful. Means it's a mathematical kind of computing in which the finding the prime factors of an integer and working with those cryptographic methods and other things in there. So there are certain fundamentals of quantum mechanics. The three of them are superposition, entanglement, and measurement uncertainty. So quantum superposition is, this is very famous example of Schrodinger's cat. So here to show the state of superposition, like if the coin is existing in both head and tail in the both states. So this is to explain superposition. We can show this famous Schrodinger cat, where it describes that if the cat is in a sealed box, so it can be both dead or alive at the same time, unless it is observed. So means if the box is closed, you do not know whether the cat can be dead or it be alive at the same time, like that. So this is called as a state of a superposition. And then the next is a quantum entanglement. It is a phenomenon where two or more qubits become correlated in such a way that their states become interdependent. So change in one state, in fact, some years ago, this became very popular about some, like we have now this James Webb Space Telescope in the space. And then some of the experiments, they have found that the particles, they are linked with each other. And if there is any change in state of one, it affects the change means in the another one there, regardless of the distance between them. Means it can be however far in between them. So like entangle two electrons, if they are spinning in opposite directions, and when one electron spin is measured, the other spin instantly aligns in the opposite direction, irrespective of their spatial separation. That one. And then the next is called as quantum measurement. Here, the German physicist and Nobel Warren Heisenberg, he gave this principle that we cannot know both the position and the speed of a particle, such as electron, with perfect accuracy. So this is the Heisenberg uncertainty principle. So the lesser the uncertainty there is any property highlighting it, the more accuracy we can measure the position and the movement of the particles from there. And then comes the type of quantum computers. There are various type of quantum computers because these are developed with the help of kind of hardware which enables the quantum error correction technique, or the maintaining the quantum coherence in that. So they are based on like gate-based quantum computers. They use quantum gates to manipulate qubits, whereas adiabatic quantum computers, they rely on quantum annealing, in which we did. Say, for example, those built by IBM and Google, they are gate-based computers. They utilize qubits to perform computations by applying quantum gates. Gate means something like the port which are allowed to transfer the data, the instructions from there. And then the quantum error correction. Here, these are very sensitive to environmental noise and errors, which can rapidly degrade the accuracy of computations. So we need quantum error correction techniques to ensure that the computation stays reliable and fault tolerant. So this is done using that. And then we have quantum interference and decoherence. Quantum interference is a phenomenon where the quantum states can constructively or deconstructively interfere, affecting the outcome of quantum computations. But they are susceptible to decoherence, a process where the quantum information is lost due to interaction with the environment. And that's why these need to be taken care of in these. Okay, go to the next. Next. So what is the current state of quantum technology? This is rapidly evolving, and researchers and companies, they are continuously making a progress in developing more capable quantum computers. So the like quantum computers with around 100 qubits have already been developed by IBM or Google. So we call it as quantum volume, a metric that assesses the overall performance of quantum computers. So this is increasing quite quite fast overall. So use cases, say like in daily life, quantum communication and secure cryptography, they are very, very powerful. They achieve unprecedented level of security due to this quantum key distribution. It allows various parties to share their cryptographic keys with absolute secrecy, and which prevents eavesdropping and tampering. And so this is one of the example which is of quantum communication, is the quantum key distribution. Then another, we use quantum sensing and imaging, which is used to detect and measure physical quantities with exceptional precision. Particularly for ultra-sensitive imaging for various applications. And one of the application is quantum LIDAR, which uses entangled photon pairs to achieve high resolution imaging in challenging environments, particularly like underwater exploration or remote sensing. So using satellites if you want to, when particularly, in fact, when I was in Guyana, and Guyana is surrounded on the north by Venezuela, on the west by Brazil, and below that in the south it is Suriname and French Guiana and like that. And there it was a common thing. Venezuela, it is very rich in oil. So the satellites there, they used to have those technologies that how you can find oil beneath, either it is the earth surface or in the ocean, because it is Atlantic Ocean in that side from here. So this is a very a great application of that for as a quantum technology in that. The next is the quantum meteorology and precision measurements, particularly like quantum sensors, which can outperform classical sensors in tasks like atomic clock synchronization or gravitational detection. We can say a sensor is a simple device. In fact, most of the things which we use, they are like sensors. A common example, you must have seen that particularly if you have a water pump, so water comes and you pump it on your overhead tank. So when the machine finds that the water has fallen below a certain level, then the sensor will send a message to actuator, and the actuator will switch on the water pump, and the water will start going into the overhead tank. And when the sensor realizes that the water has reached up to a certain level, after that it will start overflowing. To avoid that, again, the sensor sends a signal to actuator, and the actuator sends the signal to the motor to stop it. So that is the field of IoT, Internet of Things, and sensors and actuators, these things. And here the application of quantum gyroscope, which uses quantum interference to measure rotation with unprecedented precision. And this is very good for inertial sensing or navigation systems, on which like satellite navigation and these things, they go in that field. And similarly, quantum enhanced AI and machine learning, it offers a great potential to accelerate machine learning algorithms through quantum parallelism. And with the help of these, we can solve complex optimization problems and improve pattern recognition tasks. So there, particularly like for traveling salesman problems, where the goal is to find the shortest route between multiple cities and how that can be computed. And particularly if you see like we use Google app when we travel, and it keeps on computing. So if we have taken different road, it will say that recalculating, and it tells you the time and other things which it keeps on calculating from there. So what is the potential? It has a great potential to transform the landscape of education by offering unique advantages and opportunities. Particularly, it has exciting opportunities for students and researchers to explore the cutting-edge technology, encourage interdisciplinary collaboration, and foster critical thinking in technical complex problems. And particularly, there is a lot of benefit of integrating quantum computing into STEM education, science, technology, engineering, and mathematics, because by doing so, the students can gain insights into quantum mechanics, programming, problem solving, preparing them for their future career in quantum-related career opportunities. And then another is how we can integrate quantum concepts into the curriculum at various levels to grasp the fundamentals of quantum computing. Means the purpose is that how we can initiate the students' understanding of quantum mechanics, quantum algorithms, and there. And particularly here, if you see this IBM Quantum Educators Program, which shapes the to help teachers in growing to become more enabled, empowered for these to work in the growing quantum field and those things. So these are the things which are available there. And then quantum simulation for scientific research and education. It allows the researchers and educators to model their complex quantum systems, which are challenging to simulate using classical computers due to their powers. And here it accelerates the scientific discovery and aids students' understanding in for the abstract quantum concepts goes. And then developing quantum algorithms for education to introduce students to quantum computing concepts. Then they can, we can make them more accessible, engaging, and like that. And particularly like the concept of quantum game, where the students can, this quantum inspire website, they have a quantum game where the students, they can interact with a quantum computer through educational interface to solve puzzles or optimize solutions for their, to have a hands-on practice. And then the use in enhancing equity and inclusion with quantum computing, because it has the potential to act as a force for equity and inclusion in education there. So how that can be addressed is that by addressing the digital divide with quantum access to technology and digital resources among different communities. And then it can play a big role in mitigating this divide by providing access to quantum learning platforms and resources. So there are various companies like this Cointelegraph. They offer cloud-based access to quantum processors. These platforms, they allow students and teachers from diverse backgrounds to experiment with quantum computing without the need for a specialized hardware. So that is quite helpful. And then this is a quite serious issue, that the diverse representation in quantum research and education. We need to promote it because it is very crucial for building a thriving and inclusive quantum community. So it can, and that can lead to more creative solutions and broader perspectives. So this is like this website, like Women in Quantum, onequantum.org. So they are, exploring various initiatives on promoting diversity in quantum computing. And similarly, bridging the gender and racial gap, leading to underrepresentation of certain groups that needs to be addressed. And that can be done by having efforts made by the universities and institutions to have like mentorship programs, scholarships targeting underrepresented groups in quantum related fields, so that we can break the barriers and foster talent development. Goes with that. Then quantum computing with students with disabilities, that is quite a challenging task. And the work is going on, particularly like this article of a Scientific American. The role of various kind of adaptive technologies and accessible resources on quantum learning platforms. So how these tools, they can aid the students with visual impairment or hearing impairment or other kind of disabilities to engage with quantum concepts effectively. From there. Then we have these quantum education initiatives, like these advancements of quantum education, because it requires dedicated initiatives and accessible resources. So to engage students, educators, and public in understanding these quantum computers. So that can be done, like it includes workshops, seminars, interactive activities to promote quantum literacy. Then quantum computing outreach programs for like Quantum for All or Quantum Open Source Foundation, like open source hardware, open source software. So similarly, this one. And then we have quantum learning platforms They offer accessible and interactive resources for learners to explore quantum concepts and practice quantum programming. And these platforms, they provide cloud-based access to quantum processors. Similarly, quantum computing for K-12, so that means can foster early interest in quantum computing and prepare our students for future STEM opportunities. And therefore, age-appropriate materials and programs can make quantum education engaging and accessible to young learners. Similarly, collaborative projects and partnerships between educational institutions, industry players, research organizations, so this is a national Q12 education partnership, promoting the opportunity on a real world quantum project, and how that partnership it can bridge that gap between academia and the industry. So there are certain challenges and barriers to quantum computing, particularly for like ethical issues. Quantum computers, they have the potential to break classical cryptographic methods very easily. And this poses a threat to data privacy. At present, like RSA algorithms and those things, it is believed that when these quantum computings, they will come, then that will be a very big issue. So the protection of sensitive information against quantum attacks is significant ethical concern, which is the very much need. And as quantum computing becomes more powerful, the risk of quantum attacks on even classical cryptographic systems, it increases. So how those things, they can be developed, and particularly working for quantum supremacy and responsible communication. So bringing about potential societal implications for that. We need to take care of and think about how to take care of the lack of access to quantum resources, because the quantum divide is also there, because and present it is very wide. It is something like only few countries, they have the access to that, and how that can be promoted to more. So now how we can prepare educators for teaching quantum concepts. The program especially those can be created by incorporating into creating policy matters, making resources available, having academia, industry like that. Because it has a very big impact on various things, like how we need to support teachers to want to embed quantum computers that do not rely on advanced mathematics in their curriculum. So there are mentorship programs or other opportunities to practice in there. And then let us have a look on the future of technology and the impact of quantum computing on that. One is on the impact on quantum machine learning, because it is revolutionizing it, very far, enabling faster ML algorithms and optimizing the techniques. So this has become quite, and particularly most of the applications nowadays, so machine learning and deep learning applications. So this, with the help of this, it is including indeed. Then about the drug discovery, there are many fields there which are emerging out of this. So what can be the strategies for encouraging underrepresented students for quantum education? We can have early exposure, create outreach programs for them, have mentorship and role models, provide scholarship, create inclusive curricula and materials, have the collaboration with minority sovereign institutions, develop community and sport networks, like organization of public lectures, seminars, unconscious bias, we need to address it, providing a sportive and inclusive environment, and long-term engagement throughout the educational journey of the students. So this is, and then okay, I think yeah, that was the end. But I want to discuss few more things that how it is going to impact the future of education. So let me keep it this slide. So like it will be offering us a superior processing power, which can handle vast amount of data, which is much faster than the classical computers. So we will have the facility of enhanced data analysis and personalization of education. So because this capability can be used to analyze students' performance data, their learning patterns, their preferences. So the teachers can create personalized learning paths, and we can provide the individual student support and maximizing their learning outcomes. Similarly, optimization of educational systems like educational planning and resource allocation, advancement in AI algorithms, then cryptography, data security, multidisciplinary collaboration, like combining physics, computer science, mathematics, biology, other things, virtual reality, and immersive learning. It can get a quite big boost. Then quantum chemistry, because it has the ability to simulate molecular and material systems, which have a big impact on chemistry and material science education. Those things, they can go there. And at the end, I will discuss some of the fields which are on the horizon. Like we know about quantum mechanics, which is the study of behavior of matter and energy at the atomic and subatomic scale. Then quantum computing, where we perform computation at a much faster with more efficient algorithms. But then there are other fields which are emerging, like quantum optics. So how light and matter interact in quantum regime, exploring the phenomenon like quantum entanglement and superposition in photonics. Then there is quantum chemistry, the quantum mechanics to understand and predict the behavior of atoms, and which is very crucial for computational chemistry. Then quantum biology. So, exploring the impact of quantum phenomena on biological systems, like how this quantum may affect the biological processes. For example, photosynthesis or navigation in the birds. Like you must have, you may be knowing that many of the birds and even marine animals, they travel up to another place, go there, lay their eggs, and then come back. And those kind of navigation systems, or with the change of season, change of weather. Then quantum material science, which is a study to investigate phenomena like superconductivity or quantum phase transitions, and particularly that magnetic levitation for these high-speed train systems, railways out there. Then quantum condensed matter physics, which includes quantum liquids, quantum solids, or other complex states. There is another field which is like quantum gravity, which describes the behavior of gravity at the quantum scale. Quantum meteorology, which improves the precision of measurement devices like timekeeping, navigation there. Then quantum sensing, where we build sensitive sensors for detecting physical quantities like magnetic field at a particular place, or gravitational waves, or temperature. Then very important application is quantum imaging, which means with the improved resolution and sensitivity in imaging applications. And then thermodynamics, the connection between quantum information and thermodynamics, like those fields, which how it helps in that. So this is how it is bringing change in the way of not only education, but the various other fields which are impacted by these developments with that. So thank you so much, and this is all I think now I can stop my screen sharing.
Thank you. Thank you so much for that. Let me see how I appear. Oh, I'm human. Great. Nellie's back.
Nellie's back.
That was wonderful. You have no idea how just the word quantum resonates with my being. And it does, in fact, not just, just word wise, but it does with all of us. And I think becoming aware of quantum physics, which has really interested me ever since I learned about it, I think we should be aware of how things work, not just how they work now, but the potential of how they will be working. And to be able to be, an intelligent being that knows about these things. And I think that's probably the reason why you chose this topic. It's not the first time that you chose it, but it's completely different. Of course, the topic, I mean, you've gone into another area, computational quantum, computational ideas have been running with Google, apparently, not Apple and not some of the others that I would expect. I mean, I would expect Apple to be involved in this, but it's not. And that's strange enough, but Google is. And Google has been involved with this, have been experimenting with this since 2019.
Yes, they have developed, invested a lot of money, and a special division is particularly, it is believed that like one of the application for virtual reality and augmented reality, mixed reality, extended reality applications, which involve immense computing power into it.
Exactly.
And you can see the that experiment was done in India by our Prime Minister, when once he was present simultaneously at 300 places using hologram technology. So like those virtual worlds and other applications, these normal classical computers, they have a limitation. And it is believed that these quantum computers, they will be, and particularly its application in the areas of like drug discovery, particularly the study of genes and those things, which involve complex kind of computing. And I was reading that the science has progressed already. The research is there that we won't die, means we can live forever. The research is already going on, means prolonged lifespan. That's already the work is being done, because the genes, they have been identified by the system. So this is quite interesting field, but particularly I agree, and I have this understanding that currently it's a bit technical in nature. But anyway, when we started with classical computers, even that was technical, means it was not easy for the students to undergo with all those arrays and gates, hardware systems, operating systems, those things. But anyway, that's why one of the recommendation is that it is better that if we start early.
Exactly, when they're still curious, with young children who want to know how things work, who are interested, and then they lose interest at some point when they get to high school. It's all about grades. But yes, exactly. And then, we could have people experimenting with, but the whole idea of, particle, I think someone mentioned that in the chat somewhere, the idea that it's the viewer, we don't know, we don't realize the potential that we have as human beings in how we see things. Because if we, and that's why I think mindfulness is so important, if we just relax and accept our conditions and kind of go with what we have and not, go after what we don't have so much or push it away if we don't want it, is to realize that we can see things in two ways. You can see things as a particle. And when I first found out about this, and I saw experiments on this, where, you know, you could see an object both as a particle and as a wave.
As a wave, yes.
Which
Yes.
is, I mean, think about that. It just means that, you know, life as we see it when they, and I don't know why that was put in the back burner, why they stopped, you know, putting that out to the public, because the public is not aware of this. There isn't that much push in that direction, which is why I'm glad you added this presentation, because you said you weren't sure about it. But I think this is exactly what we need to realize, that there's a potential out there that we're not aware of, whether it's in ourselves or whether it's in the technology that's being developed. Imagine how, you know, maybe money is the problem. Maybe, you know, people are more interested in making money than in a lot, you know, providing people that don't have the opportunities with the opportunities to be inclusive, you know, being offering exclusiveness and allowing everybody to be able to get everything that they need is not something that is economically worthwhile. You know, there's no money in it. The poor don't have anything to offer us. You know, they can't give you money for your goods. And this is a whole, you know, approach to how things go. So I hope that the East, that doesn't have this approach so far, I hope you don't get spoiled by the West's attitude about everything is, you know, the dollar signs are there in front of you, but you know, that that you influence the West.
Yes.
That's
Certainly.
my hope.
Yeah.
So thank you. Are there any questions? Oh, I think Henda, you've got some great ideas there. Maybe you can, let me make sure that you have the ability to unmute yourself. We've got a few minutes. Yeah, you can unmute yourself and ask questions or add your comments, because yes. I don't know, you can open your mic, your video as well if you like. Yes, there. Okay, the background's nice. Plamen. Ooh, you're in as your avatar. I like it. Not that you don't look good yourself, but the avatar's nice too. So feel
That's
free
why I, in the beginning of this presentation, I wanted to take up those cases that in which we have the things around us in our real life, but we do not know that it works on the principle of like microwave. You know, most of the houses, they have it, but we do not know that what is the means, how does it heat those things, and particularly means those LED lights or other things. So means the main issue is here is that how we can make our you know, lay person more aware about the potential and the challenges, and that's why through education, I think that is the best medium when we can make them aware. And certainly when education takes that route, definitely the curriculum will be adjusted according to that, and certainly the educational programs, they will come in. So
I want to suggest something that I remember, you know, and since Plamen is here as well, for English teachers who teach, they take different topics. And I remember in one course that I was giving on the environment and the different, and I learned so much as a teacher about these things. And English teachers do this around the world. So maybe they're the ones that, you know, you can reach, because they will be very interested in using these topics to teach their students not only English, but also, you know, about quantum. I include in quantum physics and quantum computational areas. So Plamen, what do you think about teaching that? You don't know much about it, but the minute you start teaching, you learn, right?
Yes, Nelly. I would just think that I have no idea about it, but it's definitely something that I should look into.
Yeah, and you could teach it. You know, that's how I learned. Hello, Henda. I learn when I, you know, if I teach, I learn something and then I teach it. I use it if I like it, if I think that it's worthwhile.
Absolutely.
You know, what's good about the the avatar is that it's so clear, it's so precise, it's clear.
Yeah.
And that's
Yes.
what Zoom is not doing. It's suggesting that I do that I use the, I read somewhere that I should be using the avatar if I want a clear, crystal clear video. So, yes, Henda, please share. Henda. You need to unmute yourself.
Yes, I just want to say I'm not a scientist or anything, but he was talking about quantum entanglement. He was saying that two things, I don't know, like Internet of Things, two things talk to each other even though they are far apart. So I just thought that it's simple to explain this to young children. You tell them that like your parents fall in love, even if they live in different parts of the world. So yeah, this is the layman explanation of a very complicated concept.
Wonderful. Thank you. Good example.
Yeah, I think you mentioned some other ones too, but I think that's great, looking at things, from a different perspective and trying to capture it in our students. I think that's beginning. Henda, what do you teach?
I teach English.
Oh, great.
Yeah, I thought about, I teach about, before I used to teach at primary levels, then I started teaching business English at the Institute of Technological Studies. So my experience, I'm experienced with both primary children and students at the tertiary level.
That's great.
Wonderful.
You got both of them, but just don't
Yes.
teach them at the same time. I mean, on the same day. It's very hard to work with young children and then go to adults on the same day. So thank you very much, Dr. Ramesh Sharma, for this and for enlightening us and opening our eyes to other possibilities that we might want to share with our students.
So thank you so much, friends, and have a wonderful time ahead. And keep joining, listening to all of you. Yes.
Thank you. Thank you so much.